So I'm going to go over lessons 107 and 108. 107 we went over in class. It's talking about finding the equations of an align, and in a couple of different circumstances. And when we find the equation of a line, it's important to start off with knowing it's called the y-intercept slope version of a line. And the basic equation is y equals mx plus b. You guys know this. Dominic knew this in class. M is the slope and b is the y-intercept. In other words, it's where the line crosses the y-axis. So, a couple of different problems. They ask you to find the equation of a line of the point -1, 2, and they also tell you that the line is parallel. This is a symbol for parallel to the line that has the equation y equals -3x plus 1. So we start off with this basic form, y equals mx plus b. Now we need to fill in m and we need to fill in b, and then we'll know the equation. First of all, we want to fill in the slope. The line that is goes to the points -1, 2 is also parallel to this line. Parallel lines, as we wrote today in class, parallel lines have the same slope. That's really important to remember. Parallel lines have the same slope, but different y-intercepts. Okay, so the slope of this line right here is easy. It's -3. So we can fill that part in for our new line. So now we have y equals -3x plus b. Now we need to find out what the y-intercept is for this line. And the way we can do that is we are given a point that's on this line. So we are already given an x and a y that works for this line. So we know that x is -1, and we know that y can be 2 and still be on this line. So we just substitute those numbers in for here, which will leave us with just the y-intercept to find. So we're going to put 2 in for y. We're going to keep our slope as -3, and we're going to multiply that by -1, which is our x in this point. And then we're going to still remaining with the y-intercept. So 2 equals -1, or -3 times -1 is 3, plus b, subtracting b from each side, subtracting 3 from both sides, tells us that b equals -1. This is our y-intercept. So we need to take that and put it in our new equation. And so that leaves us with y equals -3x. It's -1. So instead of plus a negative, we're just going to write -1. So this is your answer. This is the equation of the line that passes through points -1, 2 and is parallel to this line. Notice that they both have the same slope of -3. I'm going to do one more finding the equation of a line before we go on to the next chapter. There's another type of question where it says find the equation of the line that passes through points -3, 7 and has a slope of, this one says 1/4. These ones are actually easier because they tell you the slope straight out. So writing down our formula of a line that we need to have memorized, y equals mx plus b. M is the slope, so we can substitute 1/4 x in for the slope, and then we're going to go ahead and add our y-intercept. Just like before, they give us a point xy, which is on our new line. So we take -3, which stands for our x, and put it in for x in this equation. We put 7 in for y right here. We add b. Now we solve our equation for b, which is going to give us our y-intercept. So we have 7 equals -3/4 plus b. We're going to add 3/4 to each side, which would give us 7 3/4 equals b. And we're going to rewrite this mixed numeral as an improper fraction, which is generally what they do for a y-intercept. So 7 3/4 equals 31/4. So 31/4 is equal to b. So we're going to put that in this equation for b. which tells us that y, the equation of our line that goes through negative 3, 7 and has a slope of 1/4, is y equals 1/4 x plus 31/4. That's our answer right there. Okay, we're going to go ahead and move on to 108, which talks about square roots. So this is lesson 108. In this lesson, they're going to ask us to solve for x, but in the equation, we're going to actually have a square root. So it'd be something like the square root of x minus 2 plus 3 equals 0. And we need to solve for x. What we want to do is something called isolating the radical. Sounds pretty cool. So how we isolate the radical. This is the radical. The radical is the term that has the square root sign in it. So we want to get just the radical on the side of the equation by itself. Right now, 3 is being added to it. So if we subtract 3 from each side, that would leave just the radical on this side and negative 3 over here. So then, in order to, now we want to get rid of this radical sign. So we want to, right now we're going to do the opposite. Right now, x minus 2 is the square root is being taken from it. We're going to do the opposite and square it. So we're going to square this side. And we're going to square this side. Make sure, this is super important, that you put that in parentheses. It is negative 3 squared. Negative 3 squared in parentheses. We want to square this whole thing. Equals 9. If you just said negative 3 squared, this is not correct because the PEMDAS, our order of operation, tells us that we need to do that exponent first. So the 3 would need to be squared first, which would make it 9, and then the negative sign would be there. So that would be negative 9. But that's not what we're looking for in this equation. We want to square the whole thing. So I'm just going to cross that out. We want to square negative 3, and that gives us 9 on this side. And whatever you square, something that is under a radical, it just is what's under the radical. So the square root of x minus 2 squared is just x minus 2. And that's simple to solve from there. We add 2 to each side, and x equals 11. So there is something to remember about these problems. You have to, after you get your answer 11, you need to go back to the original equation, which is this, and see if the 11 works. 11 minus 2 is 9, and the square root of 9 is 3. 3 plus 3, however, does not equal 0. So what that tells us is that there is no, and this is what you would write in your notebook, there's no solution to this equation. So whenever you're working with equations and solving for x that have a radical in them, you always have to take the answer that you get and put it back into the original equation, because sometimes that will show you that this does not equal, which tells you that there's no real solution. So now I want to do one that does have a real solution so that you see the difference. If we had the square root of x minus 2 minus 6 equals 0, we're going to isolate the radical. We just want this on this side. So we're going to add 6 to each side, which gives us the square root of x minus 2 equals 6. Now we want to get rid of the radical, so we're going to square both sides. Squaring the square root of x minus 2 gives us just x minus 2. It just gives us what's underneath the radical sign. 6 squared equals 36. We add 2 to each side, which gives us x equals 38. If we put 38 back, remember what I told you about with these kinds of equations, you always have to put what your answer is back in this original problem. 38 minus 2 is 36, and the square root of 36 is 6. 6 minus 6 is 0, so this does work. So this tells us that 38 is the answer to this one. So I want to try, let's try one more. We're going to try one that's a little bit different. That's the square root of x minus 1 minus 3 plus x equals 0. We're going to isolate this radical and add 3 to each side and subtract x from each side. So this radical is just by itself. which gives us x minus 1 equals 3, because we added 3 to each side, and subtracted x, 3 minus x. Now we want to square each side. We're going to square this, and we're going to square this, making sure, again, that we put that in parentheses. So the square root of that is just x minus 1. It's just whatever is underneath the radical sign. And now we have to remember, how do we do 3 minus x squared? Well, we have to remember that that's the same as 3 minus x times 3 minus x. And when you finish that, when you go ahead and multiply that out, you end up with 3 times 3 is 9, doing the distributive property. 3 times negative x is minus 3x. Now we have to do the distributive property with this term. Negative x, remember to watch the sign, negative x times 3 is another negative 3x, and negative x times negative x is a positive x squared. So now what we have is x minus 1 equals 9. We can combine these two like terms. Minus 3x is minus 6x plus x squared. Now what we do? We want to factor this one. So what that means is we want to get all of our variables and numbers on one side of the equation, and 0 is the only thing left on this side. So, and I'll show you why, because we want to get to where we can factor it. If you do these types of equations and you have an x squared, we have to remember that that means we're going to need to factor it. So if we subtract an x from here, and we're going to subtract an x, and that will leave us with just negative 1 on this side. It'll have 9, and if we have subtract an x from this side, we have minus 6x minus another x, which gives us minus 7x. We still have that x squared. This doesn't equal 0 yet, so in order to make this side equal 0, we need to add a 1. And if we add a 1 to this side, we need to add a 1 to this side. 9 plus 1 would be 10. So we have 10 minus 7x plus x squared. However, that's not the typical form that we see it in when we want to factor. We usually see the x squared first. So we're going to switch it around and say x squared minus 7x plus 10 equals 0. Now we need to go ahead and do our parentheses. We are looking for, if you remember when we factor these, we are looking for two numbers when multiplied together give us 10, and when added together give us negative 7. So that would be a negative 2 and a negative 5. Negative 2 times negative 5 is a positive 10, and negative 2 plus a negative 5 is a negative 7. So we write minus 2 minus 5 and make sure that that is equal to 0. So now we're going to have two solutions that we're going to need to check. One of the solutions that makes this equation work, remember when we have two things like this, we did this before, we have to see what do we put in for x to make x minus 2 equal to 0. And that would be 2, because 2 minus 2 equals 0. So either this parentheses needs to be 0 or this one needs to be 0. So we have to look at and see what do we put in for x to make this one equal 0. 5 minus 5 equals 0. So our answer can be 2 or 5. But we need to check. We need to go back to this original equation with both of these answers to see if they work. We will try the 2 first. So if you put 2 in here, you get 2 minus 1, which is 1, and the square root of 1 is 1. 1 minus 3 plus, what was our x? Our x was 2, plus 2. And let's see if that does equal 0. 1 minus 3 is negative 2, and 2 plus 2 does equal 0. So 2 works, so we know that that is one of our answers. Let's put in 5. 5 minus 1 is 4, and the square root of 4 is 2. We're going to subtract 3, and then we're going to add our new x, which is 5. 2 minus 3 is negative 1. Negative 1 plus 5 does not equal 0. So the 5, in this case, does not work. So the only answer for this one is just 2. So sometimes you will get no real answer at all, like in our original one, wherever it went, this one. This one has no solution. That could be one of your answers. This one has 38 for a solution, because it only had one answer. This one we had to check 2 and 5, but only 2 worked, so just 2 is the answer. Sometimes you'll end up with 2 answers for x, and they will both work. In that case, you would have both of them for an answer.